how touchscreen work. A touch screen is a bit like an invisible keyboard glued to the front of your computer monitor. To understand how it works, it helps if you know something about how an ordinary keyboard works first. You can find out about essentially every key on a keyboard is an electrical switch. When you push a key down, you complete an electric circuit and a current flows. The current varies according to the key you press, and that's how your computer figures out what you are typing. In a bit more detail, here's what happens inside a keyboard. You will find there are two layers of electrical conducting plastic separated by an sultank plastic membranes with holes in it. In fact, there's one hole underneath each key. When you press a key, you push the top conductor layer down towards the bottom layer so the two layers meet the touch. Through the hole, a current flows between the layers, and the computer knows you have first a little spring pieces of rubber underneath each key make them bounce back to their original position, breaking the circuit when you release them. Touch screens have to achieve something similar to this on the surface on your computer screen. Obviously, they cannot use switches, membranes, and bits of plastic, or they do block the view of the screen below. So, they have to use more cunning tricks for sensing your touch completely invisible. Different kinds of touch screen work in different ways. Some can sense only one figure at a time and get extremely confused if you try to press in two places at once. Others can easily detect and distinguish more than one key press at once. These are some of the main technologies. Resistive. Resistive touch screens, currently the most popular technology, work a bit like transparent keyboards overlaid on top of the screen. There's a flexible upper layer of conducting polyester plastic bonded to a rigid lower layer of conducting glass and separated by an insulating membrane. When you press on the screen, you force the polyester to touch the glass and complete a circuit. Just like pressing the key on a keyboard, a chip inside the screen figures out the coordinates of the place you touched. Capacitive. These screens are made from multiple layers of glass. The inner layer conducts electricity, and so does the outer layer. So effectively, the screen behaves like two electrical conductors separated by an insulator. In other words, a capacitor. When you bring your finger up to the screen, you after alter that electrical field by a certain amount that varies according to where your hand is. Capacitive screens can be touched in more than one place at once. Unlike most other types of touch screen, they don't work if you touch them with a plastic stylus, because the plastic is an insulator and stops your hand from affecting the electric field. Infrared, just like the magic eye beams in an intruder alarm, an infrared touchscreen uses a grid pattern of LEDs and light detector photocells arranged on opposite sides of the screen. The LEDs shine infrared light in front of the screen, a bit like an invisible spider's web. If you touch the screen at a certain point, you interrupt two or more beams. A microchip inside the screen can calculate where you touched by seeing which beams you interrupt. The touch screen on Sony Reader ebooks like the one pictured in our photo below works this way. Since you are interrupting a beam, infrared screens work just as well whether you use your finger or a stylus. Surface acoustic waves. Surprisingly, this touchscreen technology detects your finger using sound instead of light. Ultrasonic sound waves too high pitches for humans to hear are generated at the of the screen and it reflected back and forth across its surface. When you touch the screen, you interrupt the sound beams and absorb some of their energy. The screen's microchip controller figures out from this where exactly you touched the screen. Near field imaging. Have you noticed how an old style radio can buzz and whistle if you move your hand toward it? That's because your body affects the electromagnetic field that incoming radio waves create in and around the antenna. The closer you get, the more effect you have. Near field imaging NFI touchscreens work a similar way. As you move your finger up close, you change the electric field on the glass screen, which instantly registers your touch much more robust than some of the other technologies. NFI screens are suitable for rock and rogue dog environments like military use. Unlike most of the other technologies, they can also detect touches from pens, styluses, or hands wearing gloves. Light pens. Light pens were an early form of touchscreen technology, but they worked in a completely different way to modern day touchscreen. In old style computer screen, the picture was drawn by an electron beam that scanned back and forth. Just like a cathode ray tube television, the pen contained a photoelectric cell that it detected the electron beam as it passed by sending a signal to the computer down a cable. Since the computer knew exactly where the electron beam was at any moment, it could figure out where the pen was pointing. Light pens could be used either to select menu items to text from the screen similar to a mouse or as shown in the picture. Advantage of touch screen. The great things about touch screen technology is that it's incredibly easy for people to use. Touch screens can display just as much information and just as many touch buttons as people need to complete a particular task, and no more leading people through quite a complex process in a very simple systematic way. That's why touch screen technology has proved perfect for public information kiosks, ticket machines at railroad station, electronic voting machines, self-service grocery checkouts, military computers, and many similar applications where computers with screens and keyboards would be too troublesome to use. Most of us now own Apple or Android smartphones which have multi-touch screen. The big advantage here is that the display can show how a screen geared to exactly what you are trying to do with it. If you want to make a phone call, it can display the ordinary digits 0 to 9 so you can dial. If you want to send an SMS text message, it can display keyboard and alphabetical or order typewriter style quality order. If you prefer, if you want to play games, the display can change it again. Touchscreen displays like this are incredible versatile. Minute by minute they change to meet our expectation. Limitations of touchscreens. All of us with smartphones, e-book readers, and tablet computers are familiar with touchscreen technology, but touch-based PCs and laptops are still fairly uncommon. Way back in 2008, Microsoft announced that touch technology is would feature prominently in future version of the Windows operating system, potentially making computer mice and keyboards obsolete. 4 years later, it unveiled its Surface range of laptops with a smart built-in touch screen. Sales were initially disappointing but have gradually improved. Thus, most of us happily swipe away at our smartphones, phone and tablets every day of our lives. When it comes to work, we are still largely locked into our old style desktop computers and operating systems and the old ways of using them, namely keyboards and mice.